I welcome you all to our today's session on outside classroom learning. In today's session, what I would like to primarily discuss is about my insights, my personal experience that I've seen after I graduated from MBIT as a civil engineer, like the different skills that we need to know, the different things that we need to learn to keep up with the world today. Before I get started, I would like to mention that this is just my personal opinion on what I have seen. So do not limit to the content what I'm showing you today. Try to explore, try to network and connect with people who are working in industry and try to get to know more about your interested field. Let's get started. Just to give a brief overview about what we will be discussing today, first I will just um, talk about the significance of outside classroom learning, what I actually mean by outside classroom learning. Second, I'll talk about interdisciplinary learning, the importance of interdisciplinary learning, and also a little bit focus on data science. Third, I'll be talking about statistics for civil engineers and like different statistical tests and their importance. Then a little bit about software skills, the importance of software skills, especially building information modeling, some of the focus on how important building information modeling is today to all civil engineers, and also a little bit importance on knowing the background behind softwares and not just how to use a software. And last, I would like to cover a little bit briefly about interpersonal skills as well. Let's get started. So what I mean by all outside classroom learning, what it means. So we have all seen this line, learning has no boundaries or limits. So how do we actually define the boundary? And for that, we need to think beyond our university course syllabus. We need to know the application of the concepts that we learn within the class. And to do that, we need to know additional tools. And all these cannot be taught in the courses that we learn within our classrooms. So to do that, we need to take self-initiative and kind of like move outside and go learn from probably by an internship or learn softwares and use different equipments. Just to relate this, I'll start with an example. So as civil engineers, we all can relate to this example that in our first year as civil engineering student, we study surveying, right? And we learn the different theories in surveying, then we applied in the lab. We probably get like a good score in the theory exam and the practical exam, and then we feel that we are probably the best surveyor. But then after one semester, we go for extensive survey camp, and that's when we realize that we were probably wrong with our understanding about surveying, because it takes probably about 45 minutes to level your dumpy level, right? And I'm pretty sure almost all the students from third year and final years who have finished their extensive survey camp would have realized that it's very difficult to level your dumpy level without having a constant practice of using dumpy level. And probably after your 10 days of extensive survey camp, you feel proud being a surveyor when in a minute you can actually level your dumpy level. And that's what outside classroom learning is all about. It's about like going out, learning about the different applications of the concepts that we learn within the classrooms. So we are lucky enough to have extensive survey camp so that we learn the different, the practical applications of surveying. But how well do we know the applications of other topics within civil engineering? We learn about transportation engineering, but how well do we know about transportation engineering? We know about water resource engineering. Let's take environmental engineering, reinforced concrete and steel design, geotechnical engineering, geology, construction engineering, estimation, material science, and more and more. But how well do we know about all these topics, but how well do we know, how do we apply this practically when we go to work somewhere or probably when we do our higher studies? So in this particular webinar, what I would like to touch base with is the different ways by which we can apply our knowledge to real life problems, and also to just share where the world is heading towards, especially for civil engineers. So let's see some of the ways how we can apply our knowledge to like real life problems. So something that I've personally experienced is softwares. So learning different softwares, you can learn drafting softwares, modeling softwares, analysis softwares, and depending on the field that you would like to work, maybe probably you're interested in construction management. There are different scheduling tools, there are different estimation tools that you can learn. If you're interested in structural engineering, there are various analysis tools that you can learn. If you're interested in transportation, you can learn design tools, simulation tools, etc. So learning softwares is something that's very important, but what's the how do we actually understand if the software results make sense? That's something that we need to know, and that I'll be covering in the software skills section. And second, knowing equipments. For example, like total station. Knowing total station is very important as a surveyor, especially if you're planning to work in a site. You need to know how you do leveling or marking using total station and other equipments. And similarly, if you're probably going to work in a lab for your higher studies, or if you're working in maybe let's say in a national laboratory, you need to know the operation of a particular equipment. And the reason being, even though there's a lab assistant who is actually performing these tests or using the operating the equipment, you are the one who is actually designing the specimen, or you're the one who's responsible for the work that we carry out. So you need to know specifically how exactly these equipments work and the specifications of these equipments. And another important aspect as civil engineer that we need to know is drawings. How well can you actually understand a drawing? So we do probably a lot of courses in our bachelor's in drawing. They're pretty simple, right? Like you do planning, you probably prepare a elevation, you prepare a 3D view, or you prepare reinforced concrete detailing, but they are all very small drawings. But when you take an actual site drawing, which is probably an A0 sheet or probably A1 sheet, you see the detailing, it's quite dense. It's very populated with symbols and description about each symbol. So how well do you interpret these symbols? How well do you understand these drawings? And most of the engineers, most of us as students, when we see the actual drawings for the first time, we are quite intimidated with what's going around. So it's better as students, if you get a chance to do an internship, trying to learn the different ways you can interpret a drawing, and learn what are the different symbols that's used in a drawing, so that when you go to the industry as a civil engineer, you're not intimidated by these drawings. And next is industrial experience. So probably the best example I can give is internship. So when you do an internship, that's when you realize a lot of the applications of these courses. You realize how you use total station, how the surveying concepts are applied. How, if you're doing a transportation engineering internship, you learn how you design, you learn how you apply these designs onto the site, how you do leveling, how you do marking, etc. So it's very important as an engineer that you do an internship during your bachelor's program. And during your internship, try to make contacts, try to network with people, and learn from people who are working there, so that you can understand how the concepts that you learn within class is applied directly on site. And so these are just four of the different ways that I can think of right now, but there are a lot of uh, such tools that you can think of, and try and do this during your bachelor's. And so the only suggestion I can give is explore more, contact with people, talk to different engineers working outside, talk to professors, talk to your seniors, alumni, and try to contact with them and ask them about the things that they are working on, and what's the market need currently. So one such thing that I would like to focus in today's session is on interdisciplinary learning. And this is a topic that's kind of gaining importance these days, not just within civil engineering, all around the world in every single field. So let's see what I mean by interdisciplinary learning. It's pretty straightforward from the definition, that it's application of concepts from different fields of study. So it's not just limited to engineering fields. It could be outside engineering, like statistics. It could be commerce or accounting that's collaborated within engineering. You need multidisciplinary knowledge to actually execute these skills. You need to learn different skills from different field of study. Like probably if you want to do some coding within civil engineering, you need to know some coding languages like Python or Java, etc. And so you need to explore and move out and learn different softwares within different fields of study to like apply the interdisciplinary knowledge. And this is something that's gaining importance, as I said, because even in the university that I'm currently working in, there is actually a Bachelor of Science and Master of Science program in interdisciplinary learning. They club architectural, structural engineering, and mechanical engineering as one branch, and that program has a bachelor's, master's, and a PhD program. So you see the importance of applying different fields into civil engineering. And one of the important aspect about interdisciplinary learning is it's an interactive learning. Like if you want to do interdisciplinary courses, it's impossible for you to probably take a course in computer science and learn coding. But what you do instead is to talk to your friends in computer science. You work on a project together. You may have these technical events where you can actually present a project that is collaborated with different departments. Civil can easily collaborate with mechanical engineering, or even computer science, electronics, and come up with some new ideas and present all these projects. So it's an interactive learning where you learn about different fields. You apply your learning into different fields and apply their learning into our fields, etc. So just to get a brief benefits about interdisciplinary learning, this is actually a wonderful representation about the benefits of interdisciplinary learning. It's actually something that I found when I read an article on interdisciplinary learning by Jackie Gersten. So you can clearly see that it's highly engaging because you're interacting with people, you're talking to your friends or probably your colleagues in the industry. It involves a lot of brainstorming, and that's why it increases your critical thinking, your problem solving skills. It improves your cognitive skills, and it's real life learning. And why it's very important is because no engineer can work as a one man army. You take, for example, building a particular structure. You have civil engineers working there, you have mechanical engineers working there with equipments, tower cranes, you have electronic equipments using which you move these tower cranes, and you have softwares that run these electronic equipments. So it's really important that we start to appreciate the importance of different fields within civil engineering. And it gives you a chance to kind of understand or appreciate the merits of other fields. We feel probably that we work outside, it's very difficult for civil engineers to work, but it's easy for other engineers to sit inside a room and probably do their works. But once you start learning about different fields, you realize the benefits about different fields, you appreciate the merits about different fields. So it's important that we start thinking about some sort of an interdisciplinary learning. There is no limit to what you can learn. There's always options out there, and the only thing that you need is a sort of motivation and self initiative to go out and learn these things. And you don't have to pay for these things. You just have to like contact your friends. You'll have a lot of friends in different fields of engineering. Just contact them, talk to them, ask them about the different things that's coming up in their field, and think about how you can apply these skills within civil engineering. And that's very important these days, because every single engineering field is kind of slowly coming into an exhaustive stage. And that's important that we start realizing the importance of different field of engineering within civil engineering in today's world. So before we go into the specifications, I would like to show you some examples of interdisciplinary learning within civil engineering. So one such example is smart structures. So smart structures is kind of like a collaboration of civil engineering with electrical engineering. So in this type of technology, the best example that I can probably think of is fire alarms within a building. It's kind of like using sensor technology. The fire alarms, there's a sensor that's kind of detecting the danger or a smoke coming up, and it alarms the people within the building. It probably gives an audio stating please evacuate the structure. So it's important for civil engineers to know how exactly do you incorporate these technologies within civil engineering. And so you see how exactly a building is smart when you actually collaborate civil engineering with electrical engineering. Similarly, there's building mechanical systems, which is a collaboration of civil and mechanical engineering. So in mechanical systems, you design heating, ventilation, air conditioning systems, and air distribution systems. You learn about thermal and environmental systems. So that's kind of like learning applying the mechanical engineering concepts within civil engineering, or vice versa. And another application is in reliability, risk analysis, probabilistic modeling. So this is a field of engineering where you collaborate with data analysis and statistics, sort of a relationship. So in reliability, you kind of see the expectation of life of a structure. In risk analysis, it could be hazard risk analysis, where you probably track the risk of an hazard, the return period of a hazard. Then there is project risk analysis in construction field. Then you have probabilistic modeling, which is very common these days, which is primarily used in reliability and risk analysis, but there's much wider applications for probabilistic modeling as well. And then you have building information modeling. So in building information modeling, it's a collaboration of civil engineering with architecture. So it's something that we would have heard these days, that it's very important for engineers to know what BIM technology is, or the BIM concept is. So I will cover briefly about BIM under software skills. So in this section, one thing that I would like to stress on is data analysis. And it's something that we see these days, that data analysis is very common word that we hear from every field of engineering, let it be computer science or electrical engineering, civil engineering. Data analysis is slowly gaining its importance even within civil engineering. And what do you mean by data analysis? So in simple terms, what I can say is it's analyzing data to interpret something out of it. So you have a set of data, you do something to it to get something out of it. So what is that something, and what something do we get out of it is dependent on problem. And let's see some examples in the coming slides. So how do we get data? That's the first question that we need to ask ourselves. So one such way is to perform lab tests. So we have experimental tests to get data. Second way is to kind of read through some reports or journals where they have reported some of these experimental data. We can actually digitize these data, or probably take the data directly from the report and use these data. But what's important here is the availability and abundance of data. So without data, of course, you can't do a data analysis. And what I mean by abundance is a lot of data. If you just have 2 or 3 data points, you probably can't come to a conclusion. So probably if you have to make sense out of your analysis, you need a lot of data points. So if you have, like, let's say a set of 100 data points, then the conclusion that you're coming up to, that probably this analysis is good or not, is valid only if you have a lot of data points. So that's one of the most important aspect about data analysis, is availability and abundance of data. So let's kind of see some of the aspects of data analysis within civil engineering. So let's take machine learning into account. So where do we use machine learning within civil engineering? So it's used primarily in image processing. It's used for in BIM for intelligent decision making. So this is something that's gaining important these days, where we have apps these days that can scan a building and probably come up. The app will let you know if the building is damaged, or if you have a beam, if you have a column, it can actually detect that that particular element is a beam, or this particular element is a wall, etc. So all this is done using machine learning, where a lot of images are taken, and you kind of put this into a machine learning model, train the model, and later the model can actually predict what the particular component is. And if you take artificial intelligence, that's something that's taking risk and quality control into account. Design optimization is completely moving into artificial intelligence. So how do engineers do this? What software or what programming language do they use? So primarily they use Python. Python is one of the most widely used programming tool these days. And another software used is RStudio. So RStudio is a statistical software. It does a lot of statistical analysis, and you get a lot of results out of these statistical results of data. So something that I would suggest people to start focusing on is Python. Even whatever field of specialization that you like to move into within civil engineering, make sure that you know how to use Python coding, so that you can come up with some advanced assessments for the different projects that you do in whatever specialization that you take. So in the next slide, I'll show you some of the applications of the data analysis within civil engineering. It looks pretty naive that we can't use data analysis. That's what we first think. Where's the application in each of the civil engineering branches? So let's see transportation engineering, for example. In transportation engineering, we get a lot of traffic data, a lot of the pedestrian study, urban planning, autopilot vehicle study. And you know that autopilot vehicle study is something that's primary focus these days. And for all of these, you need a lot of data. This data is actually put into a machine learning or an artificial intelligence model. The model kind of optimizes and gives results, and the model is trained to take these data and give results. Let's see geotechnical engineering. There's a lot of soil data. There's you can do a soil parametric study, and the different soil properties can be calculated. Uncertainty envelopes can be obtained. In structural engineering, it's widely used in hazard risk analysis and structural reliability and design optimization. In water resource engineering, or like if you take coastal engineering or ocean engineering, it's used in tidal wave analysis. It's used in hydrological study, in return periods of hurricanes or waves. So you would have seen like there's probably an expected earthquake of 8 magnitude in the next 30 years in a particular place. So how do the engineers get to this conclusion that in 30 years there's probably another earthquake coming in? That's all a lot of probabilistic analysis, prediction models, all developed using data analysis. And in construction engineering, it's used in project risk management, in uncertainty quantification, in selection criteria. And something that I would like to stress on is selection criteria. So it's something that I read recently. I came across a paper by some construction professionals on selection criteria for subcontractors. How do companies actually evaluate a subcontractor to assign a task for the subcontractor? And they did some survey. They took some data from survey from companies, how they evaluate the different subcontractors and what criteria do they look on. And they did a statistical analysis. They calculated some mean and medians and standard deviations, and they came to a conclusion that time is one of the primary factors that the companies consider, how fast the contractor can deliver the project in. And so this type of an analysis involves a lot of statistics. A lot of knowledge in statistics is very, very important to do data analysis. And so that brings us to the third topic for the day, that's on statistics for civil engineers. So before I talk about the different methods or the different statistical methods that we use as civil engineers, it's actually a talk that I heard from an MIT professor who spoke about the importance of statistics for civil engineers. He kind of showed the importance of learning statistics in the very first year as civil engineers. So this is one of the first course that we need to know before we start learning about the basics of civil engineering. And the reason being, our job involves a lot of decision making. We make a mistake, it's going to probably affect a lot of people that's involved within construction. It could be laborers, or probably if the building is constructed, it could be the occupants within the building. So decision making is very important as a civil engineer, and it comes over experience. Of course, as a fresh graduate engineer, it's very difficult for us to make decisions on different projects that we are working on. It's probably the senior engineers who make big decisions. But how do they come to these conclusions, and how how much percentage of guarantee can they give us? It's very difficult even for a very senior engineer to give 100% guarantee on a particular project. For example, like if we consider a construction project which was estimated or expected to be finished by May 2020, we know that there's a crisis going on and there's a lot of delay in all the projects. This is something that no one predicted, right? And so no engineer or nobody can actually predict such events, and so decision making becomes very important. And this decision making brings in a lot of uncertainty in the job that we do as civil engineers. Whatever we do, we cannot deny the fact that there is a lot of uncertainty involved in our job. So this uncertainty further brings in a lot of conservatism with whatever we design, whatever we plan. There's a lot of conservatism. So one of the example of conservative estimates is factor of safety. So whenever we design something, we take a lot of factor of safety. Traditionally, people used to take like up to four as the factor of safety. So for example, like if something could take a load up to 40 kilonewton, you would divide it by 4 and say no, it can take only 10 kilonewton load. But that's very high. That's a very high factor of safety. Then people did a lot of analysis, a lot of lab tests, They collected a lot of tests, and these days we use, factor of safety, which is like probably 1.5, 1.15. And that's because a lot of experimental works were conducted, because if you use high factor of safety, you end up paying a lot for the building. So the economy is something that we need to focus on. So if you look on safety and economy are something that's inversely proportional always. So you try to make something more safe, you lose on the cost economic side. Whereas if you try to make something more cheaper, you probably have to compromise a little bit of safety in it. So you need to optimize and come up with the sweet spot of good safety and good cost analysis. So that's where you need to collect a lot of data. You need to analyze the data, understand what's happening within different data to come to a conclusion. So the first thing that we need is to collect some data, and then we need to apply some statistics to analyze this data. And so the first question that we ask ourselves is, how do we get this data? So without data, we can't do any analysis, right? So one method that I had discussed before is experimental study. So experimental study is a very common way by which we can collect data. Next, you can do some observation studies and record your observations and get the data. Next, surveying is a common method. Then sampling is another method. So these are some of the four common methods by which you collect data. Now, once you collect data, the next question is what to do with the data. You have a lot of data, but what are you going to do with the data? You have no clue what to do with the data. So again, some of the common things that we do with data is, one is to kind of find a parameter or a statistics. So what a parameter is nothing but it's one single value that can define the data that you collected. So I'll talk about a parameter in the next slide. Then another method is to display the data. So you can display the data in the form of a chart, or you can put it in the form of a graph. So graphs are one of the best ways to analyze the data, because you can see what's happening. You can see how the data looks like. And another way is to do some probabilistic modeling, fit some distributions, and these distributions are fit to parameterize the data. So you have a lot of data. It's very difficult for you to understand something out of 1,000 data points. So to kind of like bring this data down, you use a probabilistic model and parameterize the model. And last, you do some sort of statistical tests. So you can do probably there are various number of tests that I'll be discussing in the coming slides. But whatever you do, the bottom line of data analysis is nothing but play with data. You have to once you get data, you just have to kind of understand what the data is. You can do a lot of things with data. So you may do one sort of analysis with the data, then you can take the same data and do another analysis. So let's see what are the different type of analysis that we can do with data. So first, I'll focus on parameter or statistic. So as I said, parameter or statistic is one single value that can actually describe my data. So let's see, the most easiest parameter or statistic that we know is average or a mean. So I don't think there's a definition that I need to give for mean. So let's see a graphical representation. So if you have like two data, let's say data one and data two. So let's say the data one, which is the blue data, is kind of like the marks, let's say, scored in concrete technology course, and this is probably the marks scored in strength of materials course. So you can see that probably in a class of 60 students, if you have the scores of all these 60 students, it's very difficult for you to understand what the data actually mean. But if you find an average of the data, that's one parameter that you can find. And suppose, let's say that we get 78 as the value for concrete technology course, and you get like 60 as the value for 63 as the value for strength of materials course. That's somewhere we can understand that. What do we understand that if we say that 78 is the mark scored in concrete technology and 63 is the mark scored in strength of material, average mark scored, we understand that concrete technology is probably more easier to score than strength of material. But that's just based on mean or average. So another parameter or statistic is variance, which is nothing but the variability in data, which is better given in the form of a standard deviation. So let's take the same example. let's take the same example of probably the marks code in strength of material and the marks code in concrete technology. So you see that the mean value is probably higher for concrete technology. But when you see the standard deviation, you see that the highest person in the class probably has a score of 100. And the lowest person has a score of maybe 20 in strength of materials. While in concrete technology, it's much lesser. The highest person is probably in 90 or 92, and the lowest person is just 60. So you can see that it's kind of contradicting. What you understood from mean is different from what you understand from standard deviation. So when you have mean and standard deviation, two parameter, it's much more clearer for you what the data actually means. And another parameter is coefficient of variation, which is nothing but the ratio of standard deviation over mean. And then you have skewness, which is one more parameter. So this is how a skewness would look like. So an inclination of the data towards some data point. So let's say if you're looking at the number of months that we have rainy season. If you look into that, probably if you take from January through to December, it's in the central region. So that's called zero skewness. And if you take a data for summer, summer is probably in the beginning of the year. So that's more skewed towards the left. So it's called a positive skewness, and similarly a negative skewness. So if you look at this, these are just one single value that can actually define a data. You understand what the data means by one single value. But this is not all it. This is just a single analysis that you can do. Another set of analysis that you can do with data is charts and graphs. So as I said, this is one of the most powerful tool because we can visually see what the data looks like. So I'll give you some examples of charts, the different type of charts used, and some of the civil engineering applications of these charts. So let's say scatter plot. A scatter plot can, it's widely used in traffic data. So there are different applications for scatter plot. They are used for regression analysis. You can probably fit in a curve and you can fit in a model. But before you do any of these statistical analysis, you need to know how the data looks like. So that's where charts and graphs come into play. So let's take another example like pie chart. So pie chart is widely used in project cost analysis, where you can get to know like what are the different aspects that's contributing towards the cost of a building, let's say. So here you can see that plumbing takes like 31%. This is just an example, not a real life project. So plumbing takes like 31% of the total cost. And similarly, bar charts, they are probably used in material composition to study the different specimen studies, like the different composition of aggregates or cement used in different, like charts that we are using. And let's take histogram into account. So in histogram is very, very commonly used in hydrographs. And I'm pretty sure all of you who would have done the course on hydrology would have seen a lot of histographs coming in hydrographs. So histogram is used for wave analysis, wave height, and in coastal engineering, ocean engineering, it's very common. And let's take box plots into account. So in box plots, we can take soil sample as an example. So we have 3 different soil types, and we plot the data, and you can see that soil 1 and soil 2 type kind of look similar, but you can see that the mean value is slightly higher for soil 2 than soil 1, but the data is kind of similar. The range of the data is close enough. But here you can see for soil 3, the mean is also pretty high, and even the data scatter is also pretty high. And so these can be used, for different parametric study in soil analysis. And then time series analysis, it's very common in seismic data. The time history analysis is very commonly used analysis for earthquake engineering. So these are just 6 different examples that I could just think of. And there are more graphs that you can use to, understand how a data would look like. So let's look into probability models. So in probabilistic models, I would just briefly like to talk about the models and not get into the details of it. So probability models are used to parameterize a given data. So if you have a discrete data set, you use a binomial distribution, you use an exponential distribution, which looks kind of like this. If the data is actually following an exponential direction, then you can use an exponential distribution and get exponential factors into account. Then if you use a gamma distribution, you get plots similar to this. If you use a log normal distribution, you get plots similar to this. And one of the most widely used distribution in all fields of engineering, or in fact even outside engineering, is normal distribution, which kind of looks like this. So we all would have seen normal distribution. We have all studied this in math. And what exactly a normal distribution, why exactly normal distribution is so powerful these days, is because of its utility. It just requires two parameters. You just have to find the mean, which is mu, and standard deviation. If you just have these two values of a data, you can pretty much get everything out of the data. So similar to what I told in parameter or a statistic, you have 60 data points, and you get like the mean and standard deviation. You can actually plot a normal distribution and find, like, two standard deviations behind the mean and two standard deviations above the mean. That actually covers 95% of the data. So for the example that I considered, like the course of strength of materials, the average score is like 63, and you take a standard deviation of 15. You do two times of standard deviation, you get like 30. So 63 plus 30 and 63 minus 30, that gives 33 and 93. So that gives you an analysis that 95% of the class population scored between 33 to 93. That's kind of, so with just two values, just mean and standard deviation, you can plot a normal distribution and kind of come to a rough understanding about what exactly the data looks like. So if you have a strength of 60 students in a class, 95% of 60, so that's like 57 students scored somewhere between 33 and 93. That's what you conclude from a probabilistic model. So something like this is used in real life data. It's used in, as I said, it's used in risk analysis very, very frequently, and you can come to such conclusions with just such models. And the last topic under the different ways to analyze data is statistical tests. So these are much more advanced and used specifically for, if you have a specific analysis to be done, and the data is primarily giving you a particular result. You have to use different tests for these type of data. So let's say one such analysis is confidence intervals, where if you want to find the range or an interval between which a particular value might lie. So you can use a confidence interval, and from the limits of the confidence interval, let's say the mean lies between 60 and 66. So if someone says that the confidence interval is 60 and 66, what they mean by 60 and 66 is that the mean, or whatever you're trying to find the confidence interval of, that's kind of lying between 60 to 66. And if you have done a 95% confidence interval, if 60 and 66 represent a 95% confidence interval, that means 95% confidence you can give that the data lies, or the mean lies between 60 and 66. So you don't have to get scared when you see 95% confidence interval is some two values, and you don't have to worry what exactly do they mean. It's too complicated. Once you know about how to do all these tests, it's pretty easy for you to apply this on different data that you get. And then t-test is another commonly used test to find the difference between two groups. So if you take the same example as marks scored, if you want to say like the marks scored, the average marks scored by girls and boys in the class, if you get the mean average score of boys and average score of girls, you can actually compare between the two groups and come up with a conclusion whether there's a significant difference between the two groups or not. And there's hypothesis test, where there's an existing hypothesis, and you come up with something like a new hypothesis. You say that, no, I don't agree with this. I'm coming with a new hypothesis. You kind of need to show that there's data to support your model. So that's where you use hypothesis tests. And there's something called as ANOVA, which stands for analysis of variance, which is used to check the variation between two groups. It's similar to the t-test, but t-test is primarily used just for two groups, but ANOVA can be used for multiple different groups. And then you have regression analysis, and this is a very, very powerful tool that a lot of engineers use, which is of this form. You have a lot of data, you just fit a line, you fit a model, and with just that one line, you can remove the data, and just with the properties of the line, you can understand how the data goes. So it's a positive data, something. So here you can see that as the X data is increasing, the Y data is increasing. You don't need the data once you get the best fit line. So these are some of the some of the different statistical tools. There are further more statistical tools like z-test and chi-square test, and all these things are used for different applications. So once you know how to use these tests, you can apply these, in different civil engineering applications, and especially for students who are working on their final year projects. These days, it's very important for you to kind of, do a statistical analysis and validate whatever results you get within your tests, and that's very important. It's important to show that your results actually make sense out of this. So you can learn this, and even you can probably use, a paper and a pen and calculate all these values. But what happens when the data is too complex? When there's a lot of data, it's going to take weeks or months for engineers to do this, right? So how to calculate, these models, how to optimize these different statistical tools. So to do that, we need to learn some softwares. And so, since I was talking about statistics, I'll first cover some of the statistical softwares that's very, very frequently used these days. The most basic software is MS Excel, and I'm pretty sure a lot of us know MS Excel. But how well do you know how to use statistical tools within MS Excel? It's it's very common for us to know, like, adding two numbers and probably just multiplying and applying some formulas and getting it. But there's a lot more that Excel can do. There's an entire tool called data analysis, by which you can do a lot of statistical analysis within Excel. But when the data gets too complex, if you have like over 400 cross 400 metrics, it's very difficult for you to do complex analysis in Excel. And that's where programming languages like Python and RStudio come into play. So RStudio is a very very what's statistically focused software, which can do primarily just statistical analysis. But Python is a more general software where you can do statistical analysis. You can even publish a web using Python. So it's very common these days that everybody is learning Python. Even if you don't know how to apply it, start start learning how to use Python slowly. And the the biggest advantage that we have with Python is that it's an open source. You can download the software online. You can learn online. You don't have to pay for Python. You can learn using YouTube videos, and just Google what are the different tools used within Python. How do you code? And so to start with, I would suggest that you can download the software and take some basic examples. Just start with like adding two numbers. How do you add two numbers? Just Google how to add two numbers using Python. You get a program, just copy paste that within your software. You understand how the program is running, and then slowly complicate the code and try to learn how you can apply these tools within statistics or within civil engineering. And some of the other tools are like Minitab, JMP, SPSS. So SPSS is commonly used in commerce field and in social sciences. So you can see how social science. So SPSS actually stands for statistical package for social sciences. So you can see how even in social science field, people are using statistics. And SPSS is very common in industry, primarily in accounting and a lot of commerce related field. But these are some of just few of the statistical tools that we can learn. And there are hundreds of such tools, but my suggestion would be to start thinking about how you can code how you can code in Python, because it's important that we understand, we move with how the world is moving these days. So everyone's focusing on Python these days. So it's very good to know how we can code Python, and not just knowing how to code in Python, but also to know the different applications within civil engineering. That's very important. So within software, something else that I would like to cover is the different civil engineering softwares. So to just start with, one of the basic software, as I just spoke about, is on MS Excel. We can do a lot of analysis. You can even do design using Excel these days. But as I said, there are more advanced tools like coding and other softwares within civil engineering that you can learn to optimize and design your whatever you're planning to design. So some of the structural engineering softwares for analysis is SAP 2000, ETAB, StatPro, and ANSYS is another software used for finite element analysis. Abacus is a software that's used for finite element analysis. You have MATLAB, which is a programming tool. But if you haven't learned MATLAB, I would recommend you to directly learn Python rather than focusing on MATLAB. But that's again a programming tool which is used, to do a lot of matrix analysis. Then AutoCAD. I don't think there's an explanation required for AutoCAD. We have MicroStation, Autodesk Civil 3D, Rivet Architecture. These are all modeling tools. We have ArcGIS and SWAT, which is more of water resource based coding tools. I'm sorry, software tools. And then in construction management, you have MS Project, you have Timberline, Sage Timberline, Primavera, which is used for estimation and quantity takeoff. And in transportation, you have MX Road for design, and you have PTV, Visium, Vistro, and Wisdom for planning and simulation analysis. So one thing that I want to stress today to all the students who learn software is that please do not just learn how to use the software, also know how the software works, the background of the software. Do the results from the software make sense to us? Because as engineer, we need to know if the software makes sense. And this is very common that people say even monkeys can be trained to do a software. If you just teach a monkey how to click a button and probably do an analysis, it can do that. But as engineers, it's our responsibility to understand or know the background if the actual analysis makes sense. So just to give a little bit insight about this, I would like to show you an example. This is an example that I prepared. It has absolutely no physical or practical representation. It has nothing to do with a real life problem. It's just to show you the importance of understanding the concept. So you can see here, like there's some graph given here, and you have to find the area underneath the curve. And so you have some particular, let's say that this is a software that's finding the area of the curve, and you know the tool to find the area of the curve, and you enter the tool, you click the tool, and finally you get some area out here. And let's say there's an analysis, and someone says that the limit is 2. That's the code specification that the thing should not cross 2. So you got the area of 1 and it's less than 2, so the design is safe. And then you pass it on to the execution team. They work on the project, and finally there's some problem and the building fails, let's say. And then there's an investigation, and you are asked to go and check your analysis where you went wrong. You go and again check your analysis, you redo your analysis, you still get 1. Then you ask yourself what's going wrong. Why is it's still coming safe, right? But what's going wrong? Then you do something. You start applying the concept. You think that, okay, I'll do it manually, let me see what's happening. And so manually you take the area of the curve, it's half into breadth into the height, you get it's 1. And then you take the second area, you still get it's 1. And you take the third area, you again get it's 1. And what's the total area? You get it as 3. And you see that there's a disparity between the data. It's 1 and it is 3 here. And so you don't understand what's happening between the software and your manual calculation. So you again go back to you don't trust your answer. You still feel that this 3 is wrong because you trust the software more than your answer. And I'm pretty sure that's something that we all face, right? And you go back and you check that it's still giving you 1. So you think that, okay, let me go ahead and see what's happening within the software. And you go deeper into the software, and you probably check what's going on, and you see that the first area and the third area is matching with your analysis, but the second area is not matching, and you don't know what's going wrong. Why is it giving -1? And you go further deep into the software, and you realize that in the second area, it took the coordinate directly. It did not take the absolute value of the coordinate, because the software doesn't know that it should take the absolute value of the coordinate. So as an engineer, you had to tweak the software a little bit. You had to probably put an absolute value there. So when you do that, once you understand that you have to take an absolute value, then you do an absolute value analysis, you get 3 there, and there you see that you have to redesign. The design was not safe. So you see that by just doing a small error, you did not realize that there's so much going within the software. You just applied what you knew, you learned from someone, or you learned from a center how to use a particular software, and you applied your knowledge in using the software, but you did not know the background or the concept behind the software. And you did this blunder, and that's probably gonna affect a lot of lives. As civil engineer, as I said before, it's very important that you don't do such mistakes. So it's not something that I want to scare you about, but try to understand, try to realize that how important it is for us to not just know the software, how to use the software, but you also need to know the background behind a software. So whenever you learn a software, first you need to learn the software. Whenever you apply it, make sure you have some sort of a check, a manual check, to confirm that your analysis result is true or it makes sense. And it's not just something that you can use, it's only applicable in analysis tools like etabs or sap. It's even important in modeling tools like Revit, where I've seen a lot of people modeling buildings, and then they switch off their visibility, and they don't realize that they have already drawn a particular beam or a column. What they do is they again go and draw a beam or a column, because you can't see the previously drawn beam or column. You duplicate the beams and columns, and then when the visibility is switched on, you don't see the duplications because they are overlapping. And so what do? You probably, it's a building which is supposed to have only 48 columns, but it's showing 60 columns. But since you don't know the background, you think that probably 60 columns is right, and you give it to the construction, the quantity takeoff person, and he will probably get more cost analysis. When you do a cost analysis, it will probably return more expensive values. So that's where knowing the background is very, very important as civil engineers when you use a software. So one such software that I would like, or I wouldn't call it a software, a concept that I would like to cover is BIM. We all have heard about BIM, and some of you have heard BIM, but you probably don't know what it stands for. It stands for Building Information Modeling. And this is something that you hear wherever you go. You hear a lot of people talking about BIM, and you want to learn about BIM. But what exactly Building Information Modeling stands for? What exactly does it do? So just to explain what it means, it's just building a model with some information. That's what it says, right? Building information modeling. It's building a model with some information. Now, what does this information stand for? That information is nothing but space properties or material properties, time, cost, schedule, energy, etc. But what does this information do? So to understand this, let's see, for example, if you draw a line in AutoCAD, the line doesn't know what exactly it's doing. It could mean a wall, it could mean a beam, it could be in an elevation, it could probably mean a column, but the line itself doesn't know who it is. But in building information modeling technology, if you want to draw a wall, you click the wall command. You probably draw a wall, you give the size, like the thickness of the wall, you give the height of the wall, and then you give the material properties, you give the cost per unit square, etc. All these details. And then when you draw a wall, it would still look like a line, but the line knows who it is, what exactly is the function of that particular line. So a beam knows it's not a wall, or a wall knows it's not a column. So a line within a building information technology model, it knows what it is doing. So that's the reason why it's called an intelligent 3D modeling. So some of the commonly used softwares are Autodesk Revit. So there's kind of like a misunderstanding that BIM means Revit. In fact, the vice versa is true. Revit uses BIM technology to run the modeling. So Revit is one of the most commonly used software, and then you have ArchiCAD, Civil 3D, BIMTrack, Navisworks. All of these use building information modeling concepts. And there are plenty of other softwares. I think these days you have almost up to 100 softwares probably that uses the BIM, building information modeling technology. And so before we understand how BIM is used, let's see some of the background. Why exactly is BIM so important these days? Because traditionally a design team included probably an architect and an engineer, and they do the analysis. They transfer the analysis and their drawings to AutoCAD softwares, and they print the paper drawings and pass it on to the execution team. And the execution team uses these visual drawings, the paper drawings, to actually execute the plan on site. But what's the biggest drawback that you have with this is that the drawback that you have with this is it's limited to just a visual communication between the teams. If there's a lot of lack of communication, if one person misinterprets the data from the drawing, the entire value of the project is lost. Because of this lack of communication, you may have increased construction time, you will have a lot of increased costs, you can have increased energy, it'll reduce the accuracy of the building. In short, it reduces the entire value of your project. So it's important that we come up with something new. So let's see how BIM technology kind of overcomes this issue. And why do we call it like a next generation modeling? That's because BIM is divided into 4 different levels of modeling. And the first level of modeling is space management model, where it's kind of similar to AutoCAD. It takes all the 2D data into account. Then in level 2, it actually you know enhances the 2D model into a 3D modeling workspace, where you get the 3D view of the building, you get the 3D view of all the MEP fixtures that you have put in that, which look just like a symbol on a 2D plan, but now it's all a 3D view. A pipe which looked like a line probably on a plan looks like an actual pipe in 3D view. And the next level, which is one of the most important level, is simulation model, where the fourth, fifth, and sixth dimensions come into play. And here is this time, cost, and energy that's considered as these dimensions, and these are used to optimize the execution process. So you see that how important BIM gets when it comes to an actual project planning these days. And in level 4, it's an integration of all these 3 different models. It collaborates all the design and construction models into one single model, and you can probably transfer this model between different teams, design teams, construction team, and even the fabrication person. You can send the model to the fabricator, and he can easily fabricate the different elements. So now you see how easy it is for the architect to probably model the building, send it to the structural engineer. The structural engineer can export the file into the analysis tool and design the building, export the design back into the BIM tool, and then the architect and structural engineer can kind of use the same model and revise the building, and then they can transfer the same model to the quantity takeoff engineer, and they can also send it to the the person who is actually calculating the schedule and cost of the building. So you see how easy it gets, and how simpler, how accurate the model gets with building information modeling. So this is the reason why it's important for us to learn building information modeling. So as I said, Revit is one of the most powerful tools that you can learn, and I'll show you some of the examples that's been used in using Revit. So I'll show you a building example. So that's actually an architectural model. Thanks to my friend Mohit for sharing one of the project that he was working on for a course that he took. So you can see that that's an architectural, that's a landscaping view. You can see the exterior of an building. And for the same building, you can do the interior designing using Revit architecture. Using the same model, you can also get the room schedule. You can get the total area of the different rooms within a building. And you can probably do a cost analysis as well. And this is for a different, this is actually something that I took from the Autodesk web page. So you can see here the cost data is input, and you get the total cost of the project. So even if the engineer, the structural engineer, or probably the architect change something within their models, it'll automatically update here, and the construction person do not have to worry about the changes made by these people, because it's within the same model. There's a lot of transparency between the data. And this is another project, but just to show you how a structural model would look like. So that's how a structural model would look like. You can just see the beams, columns, and slabs, or foundation detailing. And it's not just used in buildings, it can be used even in bridges. So that's a cross section of a bridge. That's actually a 3D view of one span of a bridge. And you can even prepare walkthroughs. So this is a walkthrough that was actually prepared for just a course. So it's not very sophisticated, but you can see how you can detail the bridge that the model, and you can use these different properties and specifications to kind of define what exactly you want to model. And you can see how the detailing is done here. It's very simple. You just have to you just have to define it once, and it's all done automatically. You can do these landscapes, you can put water bodies, you can put different landscaping features like trees and bushes and green spaces, etc. So it's visually very attractive to use a walkthrough. So that's the power of using these building information modeling tools. And so coming to one of the last topics for the day, it's on interpersonal skills. So what I mean by interpersonal skills, I mean, it's something that we all don't focus when we do our bachelor's. We are least bothered about interpersonal skills. We are primarily focusing on the courses that we do. We probably focus on our projects, but we never try to develop interpersonal skills. So what do I mean by interpersonal skills? It's primarily communication skills. So how effectively do you communicate between people? How well do you interact with people? It's very important that you can communicate effectively and efficiently with people, so that you can network with people, you can talk to people, and you can build contacts only using good communication skills. And then good presentation skills. How effectively do you deliver your ideas, your thoughts? And I'll show you some of the examples where you use all these as civil engineers. And next is listening skills. So you may come across a lot of people who love to talk. They love to talk, but the problem is they don't like to hear you. They are just like radios. They just talk, but they don't listen to you. And the problem is that when you just like to talk but don't like to listen to others, people don't like to talk to you, because they would like to share their experience with you, but you don't give them a chance to probably share their experience. So it's very important that you develop listening skills as well. And how well do you listen? How efficiently do you listen to another person? And then professional attitude. And professional attitude, there are several things. One such thing is giving respect, not just to your superiors, but also to your fellow colleagues, because you don't know how well you will have to like work as a team. It's important that you respect each other. You need to value time, and time is money for a civil engineer. So you have to value your time, as well as your team members times as well. And then personality. How well do you dress up for probably a team meeting? How well do you present before them? How well do you communicate with them? All this come under personality. So let's see some of these applications of these interpersonal skills as civil engineers. So our work is not just a one man army work. We can't build a building just by ourselves. Ours is a teamwork. You have to talk to people, you have to communicate between laborers. So teamwork is something that we face on a day to day basis. And it's important for us that we communicate efficiently. And then team meetings. In team meetings, you have to present yourself, you have to communicate and show why what you're saying. You have to deliver your thoughts effectively. Then in bid meetings, when you have to bid for a project, you probably have to even if you come up with the best bid, you have to present your bid pretty well, so that your client likes your project. So then request for information. When you have to request for some materials, you time to time, construction engineers come to this thing that they need to send a request for information regarding some material or some labor supply, etc. And then you have negotiation. And it's straightforward. For negotiation, you need to have good communication skills. And then relationship management. It's important for you to maintain a good relationship with your clients, so that you don't lose them in future. Then when you have to present your designs, even if your design is the best, to present it, and how efficiently you present matters a lot. And finally, something that's very important these days is networking. How well do you connect with people? How well do you know people in the industry? It could be alumni, it could be your seniors, it could be professors, it could be people working in industry. You need to connect with them. And the best way you can connect with them is to if you know somebody, talk to them and get contacts. When you go for internship, communicate with your superiors and kind of build contacts there. So these are some of the applications. These are just few applications that I could just think of, but there are more applications for civil engineers with respect to interpersonal skills. And so it's easy to talk about interpersonal skills, but how do we develop these skills as as a student? When you're probably doing a bachelor's, what should we do to kind of develop this skill? So something that I can think of, there's one thing that I can tell is to take part in some technical organizations like Indian Concrete Institute, or institution for engineers, and such technical institutions. If you can, if you have some contact, and you get to attend workshops, you get to attend seminars, webinars, and you can also give webinars in such organizations. So these are some of the places where you can actually develop some of these skills. You can attend conferences, you can publish a paper, you can present a paper, and kind of do something sort of presentation point of view. Then take up leadership roles. You can conducting a fest within our department. That's kind of where you can take up some leadership roles. Then working on team projects for different events, technical events, so that you not only just develop your interpersonal skills, but at the same time you're doing a lot of brainstorming within civil engineering. So that's another thing that you can use. And networking and building contacts during internship. So as I focused before, it's very important that you network, and that's something that I want you all to think about and take it very seriously. That it's kind of, the world is moving towards a place where we are having a lot of engineers, and everything is getting exhausted these days. And the only way by which we can kind of show that we are important in the market is to present ourselves, talk about ourselves, and sell ourselves in front of people. So it's important that you start networking and think of, like, building contacts. So this kind of brings me to the end of the session. So let's see some of the key takeaways that from today's session. Something that I would like to recommend to all the students to keep in mind. One thing that you need to keep in mind is, do not limit yourself to just classroom. And by this, I don't mean that you need to bunk class and go for a movie or something like that. But what I mean by do not limit yourself to classroom is to think beyond the courses that's taught within the classroom, to sharpen your software skills. You can, even if you know a software, practice the software, take actual civil engineering applications examples, and then brush your software. It's easy to learn a software, but as I showed in the example, it's important that you know understand how the software actually applies within our field of study. And another point would be, like, working on developing different interpersonal skills, like as I showed in the previous slide. You can work on some interdisciplinary projects with your friends, so that can help us a lot. And another thing is to take part in technical events and cultural events, as I focused. Try to publish some papers or present some papers. It's difficult to probably publish a paper, but try to present a paper or a poster. It's very easy to come up with some idea, some review paper, or a poster presentation. And it's very easy for you to find these conferences. You just have to, like, look out um, on different web pages to get some information about it. And last but not least, but I would like to recommend that you all start focusing on networking with people. It's very, very important that you network with people. And the best tool we have to network with people is LinkedIn. So create a profile if you don't have one. Create a profile. Make sure that your profile is very good, because worldwide professionals can take a look at your profile. So it's very, very important that you prepare a good profile, and start sending requests to connect with people, and start networking and talking to people. And it's not a place that you need to connect to people and start asking them to give me a job, but it's a place where you contact with people, connect with people, ask them about what's coming up in the market these days. And talk to them about some of the projects that you did, and see how important these projects are, or how relevant it is to the industry these days. So it's really important that you start focusing on networking. So with that, it brings us to the end of the session. That's all I have for the day. Thanking you all for your patient hearing.